Hello, everybody. I tried to click the right button, so I've got controls of the buttons here, and I must have misclicked something. So we're not here at the moment, or we are here at the moment.
Yeah, I
but
think we are here.
I don't know what's going on. Like I'm clicking all the different overlays, and nothing's happening. So I don't know if it's me or whatever. But anyway, we're all here. The bold, the broken. So Guillaume is supposed to be here. I think we'll call him the broken. Georgios is here by himself, so we'll make him the bold. So yeah. So yeah, I'm getting. Yeah. All right. So, hey, Georgios, how you doing?
Hey, how's it going? It's been a while.
It's been a minute or two, hasn't it? Let's get your screen share. Ooh, that looks fun.
Nice.
Ooh, Merry Christmas.
Nice.
All right. So, what do we? Joining this episode, I wasn't sure, based on the title, what we were going to talk about. So, I guess I'll let Georgios introduce.
Well, yeah, it's one of those totally
clickbaity
titles. Yeah, well, this is it's essentially a talk Guillaume and I gave at DevOps Belgium this year, where the idea is that we wanted to go over a few lessons that we learned since it's been 6 years now since Quarkus started, or actually more than 6 years, right? So yeah, we've accumulated a fair amount of knowledge. We've made our fair share of mistakes, maybe more. So yeah, we thought it'd be a good time to discuss it. So we did it Belgium. It was good. And then we thought we'd revisit it here because, DevOps Belgium is amazing, but there's just so much content there, right? Like there's no way you can consume all the content. And there's so much good stuff there too. So we thought that it'd be a good idea to present this here. So let me see.
And we've got Guillaume now.
Excuse me?
We've got Guillaume.
Oh, wonderful.
Yes, so you have a friend.
Awesome.
So it's not broken anymore.
Cool. We fixed everything.
In lightning speed as usual, right?
Yeah. Cool, Guillaume. Give us your opinion.
Well, my opinion on what?
What
I just joined.
the talk is about.
Yeah, so the fact is that when we started Quarkus, it was all of an experiment on how we could reinvent the Java ecosystem and how we could make things better. So obviously, when you do that, you make mistakes. And we did fix some of them, if not all of them. But that's the whole point of this talk we did at DevOps and why we are here today.
Awesome. Okay, so I have not changed the slides at all, right? Which means that we're probably gonna have to skip a few because, like, in the context of this call, like this does not make sense. Like everybody, hopefully on this stream knows what Quarkus is, right? So we don't have to go through too many details of what Quarkus does at build time and how that's different from all the other frameworks out there, right? Like I'm sure this has been discussed ad nauseum on this call, but like if there are any questions, like absolutely we can stop at any point and discuss anything you guys want, right? So again, what is so the amazing developer experience features we all know about in Quarkus, like dev mode, live reload, dev services, continuous testing. We've already covered that many times. But like Guillaume said, they were a reimagination, let's say, of how to do development in Java, and they brought along with a lot of the cool features they brought in a host of problems as well. Right? So we'll try and distill some of those right now, right?
Can you go full screen, Georgios?
Oh yes, I can. But the problem with that is that I don't remember who does what. Okay, so this one is Guillaume, right?
Yes, and So yeah, that's what I was saying earlier. It has been 6 years since we experimented with the first prototypes for Quarkus, and we thought it was a nice time to introspect and see what we were doing right or wrong. And obviously we did everything right. At least we did a few things right, because
Shortest Quarkus Insights episode ever.
But to be fair, we also had a few bad ideas, or at least things we didn't expect would turn the way they would turn. So let's see. Let's dive into what we actually did. Not that great, but also we want to underline the good ideas we had, and what makes Quarkus so different and attractive.
Right. Yeah. So one of them was starting from scratch, right? So give us your opinion about that.
Yes, starting from scratch is hard, and it's a lot harder than it used to be. I mean, 20 years ago, you started a Java framework. There wasn't that much infrastructure that we have nowadays. You didn't have so many testing frameworks, logging frameworks, and so many other things. You didn't have the containers. It was a lot easier to start because you had a lot less things to cover. And even if we started with all the lessons we learned from GBoss, EAP, Wildfly, the experiments that were done with Swarm and Thorntail, the fact that we are based on Vertex, the fact that we are reusing a lot of the components you all know, Hibernate Validator, Jackson, and a lot of others. Even with all of this, it's still hard to start from scratch. You have a lot of infrastructure to set up for your CI, for your website, for your documentation, what we did with the Quarkiverse to host the extensions, the code.quarkus.io, all this you have to create from scratch. And you always have this guy coming with, oh, I'm using this obscure library and it doesn't work. What can I do? And then you have to figure out what in our very novel architecture is actually not working with this specific library. Because also, I think what makes it harder is that we reinvented a lot of things. And our architecture is very different from your typical Java framework, which means that it's a lot harder to fit in the overall Java ecosystem, which is extremely vast nowadays.
Yeah, I mean, you can get a sense of how big the ecosystem is, because if you look in the Quarkiverse, if you include the unlisted extensions, there's almost 1,000 extensions in there, so counting Quarkus and Quarkiverse. And like that's a lot to bootstrap from scratch. It's a lot to bootstrap even in 6 years.
Yeah. Yeah, and as I said, we started as an experiment, and from there was a lot of organic growth. We are adding new features. Typically, we didn't have the dev services at the beginning. This is a new feature, and at some point, you add new things, you tweak things to make room for these new shiny things. But sometimes you have to take a step back, try to regroup, understand how you can change your model to better fit what was added these past few years. And so we already addressed a few of these issues, and we will address a few more in Quarkus 4. And the idea is to try to find the time from time to time to take a step back and see how we can evolve the whole architecture to better fit the new features that pop up.
Yeah, and I want to add to that like Quarkus was like a magnet, right? The project itself was a magnet, meaning that it brought in a lot of people that weren't initially slated to work on it, like myself, Guillaume as well. Like we weren't part of the initial group, but we saw how cool it was basically, and how much sense it made, right? But what that did essentially is that when you have a lot of disparate people coming in with different skill sets, different ideas, stuff like that, doing cool stuff, what it does is, although in the initial phase of the project, that's great, right? When you get skilled people coming in and like doing their thing and needing minimal oversight, just delivering, that on the one hand, that delivers a lot of features, but on the other hand, like it creates like disparities between the different parts of the framework, right? So what Guillaume says here makes absolute sense. That at some point, as the framework matures, you need to take a step back and say, okay, you know what? Like we've done like 10 different things, or we've done like this thing in like 3 different ways, right? We have to like come up with a common approach, or like we've done things that are similar, and we're spreading our efforts like here and there, right? Maybe we should consolidate it into like one thing. And there's a lot of that going on, right? And it's I believe it's like the natural life cycle of a successful project, right? And a project that is still living and delivering new stuff as well, right? It's not like maintenance.
And then like a successful project and a really successful open source project as well, because it's not like there's a common reporting chain for everybody who's contributing. They come from all sorts of different companies and that kind of thing. And so then of course there's going to be that diversity means that there's going to be a bit of fragmentation.
Yeah, absolutely. I mean, we were so lucky, and we'll talk about it more. We're so lucky. We had a lot of people coming in from different companies. They're very skilled, put in a lot of work to bring in amazing features that we either would have never thought of or would never have the time to do. Like these people brought in their ideas, they did great work. But again, some like you said, Holly, some of the times like it didn't fit perfectly into what like the framework was designed to do initially. So we occasionally need to take a step back and like do some retrofitting, right? Okay, so let's get to some of the like absolute basics, right? About what we did good, well, or what the project looks like, and what we did good, what we didn't. Okay, so currently, like initially, the project was one gigantic, massive monorepo, right? So it was like Quarkus.io/Quarkus repository, well, GitHub repository, which contained everything, right? That's where we started, and it was really good initially because like everybody just had to do one thing. Had to check out like one repository, build one project, work on that. And because like a lot of the aside from very few modules which were core to everything else, people could mostly like focus on like let's say you're doing like GraphQL, right? You want to add a GraphQL extension. You mostly had to just work on your area, right? That was very good. It made reporting issues much easier for people because it was like one place. It made running CI much easier. It made releasing much easier, right? But as the project grew, right, and it's still like, make no mistake, the core repository is still massive. That there's no question about that. But we've taken steps to like break it out and move stuff into the Quarkus, stuff like that. The reason is that as like a Maven project grows, right, it becomes very challenging for IDEs to import the whole project. Like even now, people come and say, "Oh, you know what? I tried to import Quarkus and it didn't work in Maven and IntelliJ, whatever." It usually mostly works now because like Maven 3.9 is much, in the later version is much better. IntelliJ latest versions, they even use Quarkus as a benchmark to how fast they can import a very large Maven project, right? So we even us as at the size of the project has made other projects better, right? But it wasn't a path that was scalable. So at some point we had to figure out like, how are we going to break this out? How are we going to like help people contribute? Like, let's say someone has like an extension for like some obscure library, like Guillaume mentioned before. I don't know, like some money thing, right? You shouldn't have to be like check out this giant repository just to work on one thing, right? You should be able to have that in a second repository, which is what we have now with Quarkus. So the Quarkus,
I got one question, if you
Yeah,
don't
yeah.
mind me. So, are we glad we chose Vertex as the baseline? I think I know the answer to that, but
we'll talk about that later, yeah. But
okay.
the answer is yes, but yeah, I'll talk about that later. So the Quarkus, right? The Quarkus, it didn't exist for, Guillaume probably knows better, but I think it came in like, I don't know, the third year of the project, maybe even later, I'm not sure. Because it essentially addressed the problem that the main repo was getting too large. It was becoming harder for people, occasional contributors, to like follow along, see what's going on, and try to make their extensions work. And what it brought is, for me, like for me now, what it brings to the table is amazing, right? Because you as like, let's say an author of a library, you want to create a Quarkus extension. It's super simple because Quarkus sets everything up for you, right? All the GitHub templates are set up. The releasing to Maven Central is all set up. You don't have to worry about that. All you have to do is just like worry about creating the best possible extension for the library you want to support, right? And for example, if you just want to release, right? All you do is like create a Git branch, push a pull request, where's a pull request, and everything else just happens automatically. That, in my opinion, like that way, the way of like unlocking that kind of velocity for extension authors is amazing. And then there's also like the documentation aspect of it, or where all of the documentation of the Quarkus is like published automatically, and it's super good, right?
I can definitely attest to that. I know we just launched a new open source project as part of Dockling, and like getting the code there is the easy part. Getting all this other crap of publishing to Maven Central, an automated release process, code scanning, all that stuff, that took way longer than the actual coding of the thing itself.
Exactly. And yeah, and the Quarkus just like handles most of that. And then Guillaume can say a lot more. I'm sure I'm missing some stuff, right?
Yeah, but actually, I think one of the main changes that we used to, as a core maintainers of the Maven of the mono repo, we had to vet every extension, vet every change, and that meant that basically, even if you were maintaining an extension, you weren't actually maintaining it, because we were actually checking everything and approving everything. And the fact that with the Quarkus, we were able to give you the keys of the repo and say, okay, here is your repo, it's your extension, you maintain it, you're the owner of it. It empowers the community a lot more. We have typically for Amazon, for everything AWS, we have one person, Sebastian Croxel, who is maintaining the extension, and he's doing it. Sometimes he pings us to have some opinion, advice, or whatever, but he's doing it on its own, and it's now basically the case for most Quarkus extensions, and that's really cool. And also the fact that we decided to centralize things, and that means that we don't have orphaned extensions, because if you have someone who is not interested in maintaining the extension anymore, but you have people coming up and say, okay, we want to maintain this extension for some time, we will check what they are doing and approve the pull request, but at some point we might be able to give them the keys of the repo and make them the new maintainers. And that's also quite cool to have centralize this while also empowering the community and make sure they were able to maintain their own extensions.
And yeah, and I can confirm it really is very sort of open and accessible, because I have a couple of completely stupid extensions in there that, like, there was no way that they would make sense to go into the main Quarkus repo. But like, I've got my Rockstar Lang extension and I've got my Minecraft extension, and because it's open, they can be in the Quarkus, and then I don't have, as Eric says, all of that hassle.
It was super easy. Like, it really makes you think about it. I know I'm hitting on this a couple of times. It really, when you don't have it, it's like, oh man, I really
agree. Yeah, I agree completely. Okay, so one thing we've messed up so many times, right? Naming, like, first of all, the project again started in like 2019, right? So back then, like all the rage, like cloud native and Kubernetes and reactive, everything, right? So we, aside from correctly choosing a reactive foundation, which we'll talk about, we stuck the name reactive into everything, right? So we had REST Easy Reactive, we had reactive messaging, then we also have like Hibernate Reactive, right? But that the naming was just horrible because it created so much confusion. For example, like when you told people REST Easy Reactive, like the first thing they say is like, no, I don't need that. I don't need reactive. I just want regular blocking JAX-RS or Jakarta REST, right? So they're like, why should I use REST Easy Reactive? And then you have to come tell them, well, no. REST Easy Reactive isn't only for reactive. Like, what? But like Hibernate Reactive is only for reactive, and you have Hibernate ORM for blocking, which is totally weird. And there were reasons that the name REST Easy Reactive was used that we can't go into. But initially, the project was called Quarkus REST. It was changed to REST Easy Reactive, and now we changed it back to Quarkus REST, which is the good name, right? Quarkus REST is exactly what it should be. It's a REST, Jakarta REST implementation. Right? Now, again, and for reactive messaging, we initially called it reactive messaging. Now we're calling it Quarkus messaging because that's what it is, right? You have a framework that you use to do messaging, whether that's Kafka or Pulsar or whatever, RabbitMQ, right? But it doesn't have to be reactive. Your code doesn't have to be reactive. Your code can be blocking, right? And it probably should be in most cases. For the case of Hibernate Reactive, the name stays because the project Hibernate Reactive is only about using an ORM to access a database in a reactive manner. So in that case, you do have like Hibernate ORM and Hibernate Reactive. Right? I don't know if you folks have any other instances of our terrible naming conventions. Well, I do actually remember in the beginning we were mixing like micro-profile names with small right names. It was a big mess. Now I think it's mostly small right. But yeah, if you have any others, like I'm sure we've messed up a lot of the time.
Quarkus unit test is not a good
yeah,
one.
yeah. Well, yeah, for extension authors, yes. Which most people, anyone that doesn't write an extension doesn't know what Quarkus unit test is. But for those who have, Quarkus unit test is like a horrible name.
Yeah, it should be called Quarkus extension test.
Yeah, it's not a unit test in any shape or form, right?
Yeah.
We can still fix it, right? It's not Quarkus 4 yet.
Yeah, no, it is so totally on my list to do, and it's like probably like a 20-minute job, and I haven't done it. But yeah.
Yeah, so lots of bad naming choices everywhere, right? But we're learning, we're getting better. I mean, I strongly believe that the choices we have made to change names are all for the better, right?
It's just one more thing that no matter how senior you are, naming is still hard, right?
Oh, I think I'm worse now, right, than I was when I was younger. So yeah.
Well, because you actually think about it now and you go back and forth, or before you just come up with something and you go with it. You don't think about it. Now we think about it.
Yeah, the fact that we have Open Read right now and Quarkus update also helps with this because we were able to make these transitions mostly harmless for our users and transparent. So that's quite cool to be able to fix it a bit later.
Yeah, exactly. So when you start out, you don't have this kind of tooling, right? Obviously, like it's not a priority. Like having a Quarkus CLI when you start out the project is not a priority. But as the project matures and this thing comes up, then you do want to invest time in making this sort of change easier for users. And Guillaume and the rest of the folks that are involved in the CLI have done great work around that. Right? So let's move on because I think we have a lot of ground to cover. Okay, so yeah, this one's Guillaume.
So the build time tooling, we did things right with the build time tooling, and that's fortunate because it's one of the core features of Quarkus. So what we have when we build Quarkus, when you build an app with your regular framework, what it does is it compiles It adds a few metadata, and then you have a jar, and then you execute the jar, and that's pretty much it. When you build a Quarkus app, we actually do a lot of things. And these things are organized as what we call build steps. And a build step is something that will consume some build items and will produce some other build items. And the whole build system is built as, oh, I need to produce this. Build me a tree that allows me to produce all of this, and then you will execute all the build steps in order with all the dependencies covered to get to your result. Your result being most often than not a jar. That's highly parallelized. So when you build the Quarkus app, we actually start a bunch of threads to cover all that's needed to end up with the production of the jar. And let's go to the next slide. One important part of this is that we need to know what's in our class path, because at build time, we actually will detect that you have this annotation, this is a bin, this is another bin, and then you build the model of the application and you can wire everything up. And that's one of the things that makes Quarkus fast at startup is that we index everything at build time. We find what the application is about, and we wire everything to make the application faster at startup. So for this, we needed an index of the classes and the annotations, and this is where we use Jandex. And Jandex is really one of the foundation of Quarkus. And if I take an example of Hibernate Validator, for Hibernate Validator, you have to find everything that is constrained, all the constraints that are used, not null, not empty, whatever. And then from this information, you will actually be able to figure out which classes are annotated, which methods are annotated. And that's how we will produce the Hibernate Validator metadata. And all this discovery, you do it at build time, and that's where Jandex shines. And it has been a very important tool in Quarkus and a key part of our success.
Agreed. Another one part of success.
Yeah, another big part of what we do at build time is that for all this information we have with Jandex and a lot more information, we will actually generate some bytecode. The bytecode will then be executed when you start your application. And so bytecode generation, usually you use ASM. It's very low level. And it's kind of hard to write, and it's even harder to figure out what you wrote when you go back to this code 1 year later. It's like, oh, what I am doing. And one of the first foundational elements of Quarkus was to write Gizmo, which is a library which allows to write bytecode in a more natural way and handles a lot of the quirks of writing bytecode for you. And it allowed us to write bytecode a lot more naturally. And I'm pretty sure that for some of our features, if we had to use ASM, we would have just said, oh no, we won't do it, just too complex, it won't be maintainable. And Gizmo actually allowed us to have new ideas and create new things. And so we have been working on Gizmo 2, which is now part of Quarkus. And I think nowadays, most of the bytecode generation now has been rewritten to Gizmo 2. And Gizmo 2 is now using the class file API that was introduced in Java 21. Java 21 class file API.
Yeah, 21. I think it's finalized maybe in 22. But anyway,
it has been improved a lot since then. It's actually a lot faster in Java 25, for instance. Mm-hmm. And so Gizmo 2 is now based on the class file API, so the standard Java API to write bytecode. So yeah, Gizmo, I think if we didn't have it, we wouldn't have done half of what we did for Quarkus. It was a huge enabler for features, and also I think we would have had a lot more bugs if we had to write the bytecode with ASM. So yeah,
it would have been close to impossible. Yeah, we should just say that, okay, yeah, you mentioned like Gizmo 2 is in Java 21, but I don't want people to be worried because we backported the class file API to Java 17, right? So you can continue to depend on Java 17. You don't need to bump to Java 21 or 25 yet, right?
Yes, exactly.
Yeah, so Guillaume came up with these cool little images.
Yeah, so these were the good things about our build framework, and then there are a few things that are a bit more problematic. One thing is that the fact that we are doing things that are extremely specific means that we have our own tooling, meaning our own Maven plugin. And there are a few reasons for that. We have our own resolvers because we have dependencies that are visible at runtime, but we also have dependencies that are only visible at build time. And now some of them are only visible during dev mode. So you need some specific build infrastructure. And when you have your specific build infrastructure, that means that you have to maintain it forever. And when you have important shifts in the ecosystem, for instance, the move from Maven 3 to Maven 4, you might have to do the work to make sure that your plugins are compatible with both. And it's even harder for Gradle. Gradle is a lot more flexible than Maven, so it's hard to find the right way to do something. And also sometimes the right way to do something in a version won't be the right way to do something in the next version. And they move fast, so it's hard for us to follow what they are doing. And also we don't have that much expertise in the team, so we are struggling even more with Gradle than with Maven. An example of the problems we can have is that in your typical Java framework, build reproducibility is relatively simple because you have the Maven jar plugin. You have the Maven compiler plugin compiling things. Then you have the Maven jar plugin assembling the jar. They solve build reproducibility there, so you don't have to care about a lot of things. Just that the files you include, usually the metadata file, your manifest or whatever, they need to be stable, but that's pretty much it. For Quarkus, we built our own jar layout, which is called fast jar. It explodes things in multiple jars. So we have our own format. So we need to implement build reproducibility ourselves. And some of the issues we had are relatively simple to fix. You need the content to be stable, so you don't want a timestamp in your jar because it won't be reproducible. But then, remember we talked about the fact that we parallelize the build steps, and the build steps generate bytecode. And so you need the build steps and the bytecode generation to be completely stable from one build to another. And this is hard. This is for most of the bytecode we generate is relatively simple because it doesn't depend on anything. So you just generate classes, and you can even generate them in another order because you don't care about the order, you just generate independent classes. But for some of our infrastructure, we actually depend on the order of generation because we have some counters for uniqueness and things like that, and to keep track of what has been generated. And in this case, we have some issues. So we made some good progress there, but we still have a few issues in the generated bytecode that we have to fix and improve. And that's an example of the issues we can have when you have your whole own built infrastructure.
Okay, so now on to our native story, right? Quarkus from day one has supported building native images with tight integration with GraalVM, right? And the way we envision this, right, is that Quarkus, when you do like a Quarkus build or npm build that package, sorry, dot minus dash native or p native, then it creates a jar, right? And then that jar contains a whole lot of stuff that is loaded essentially at class load time. And then you feed that jar to native image. Native image runs the build, and because a lot of the stuff is loaded at native image load time, a lot of stuff ends up in the heap that the GraalVM can snapshot, right? And then it creates a native executable, and when the native executable starts, it has all this stuff already preloaded, so it starts up very fast, and it can eliminate a huge amount of code, making the jar smaller, right? And the footprint a lot smaller. So that's been our basic idea about native image from day one, and it continues to this day, right? I should say that when the project started, GraalVM did this build time initialization of classes by default. It no longer does that, and it has steadily been moving into the other direction, to be honest. The reason is it wants to be as compatible as possible with regular Java, but we see GraalVM as like the enabler for the absolute smallest executable possible, right? So that's why we keep the build time initialization, but we are thinking about how to make it easier to enable or let's say disable the build time initialization for user code, right? But anyway, the vision stays the same. Now, what this did is that it was a very good decision in making GraalVM native images as have the smallest footprint as possible, right? But the bad thing it did is that it causes various issues with libraries that do certain things at at class initialization time, right? So essentially, in most user-driven Java code, you almost never see a static block in class, right? So because most user code is business code, so you don't see this static open up a block, do something, right? You rarely have to do that. But in libraries, in advanced libraries, they have to do a whole bunch of things. You can often see this kind of thing, but what happens is that because, like I said, those classes that are the class initialization is done during native image build time and not at runtime, what happens is that you end up with a heap that contains a whole bunch of stuff that is not allowed essentially at runtime. So anything that's random, right? Random is supposed to be runtime random, right? You can't have the same randomness when you're running, let's say you're running 10 instances of the application on Kubernetes. You don't want all those 10 instances to have the same randomness. You want to have a different runtime dependent random. So GraalVM disallows the use of random and various derivatives in the static init. But because we load these classes at static init time, it means that we have to take extra steps in order to ensure that the randomness is random. Or libraries, some libraries even start threads in the class initialization time, right? And that's completely disallowed in GraalVM, right? So in that case, we have to go to patch libraries and stuff like that. So what I'm saying here is the choice we made for our users to give the users the smallest possible binary and the least possible footprint has increased work for us, not insignificantly. Let's put it that way. Like I said, we're reconsidering this choice basically not for all code, but just for user code. Now, dev mode and test infrastructure. Now, so dev mode basically it existed, I think, probably from the first public release of Quarkus, and it's basically like a killer feature because it enables zero configuration, live reload in an enterprise Java framework. So that was without any tooling, any additional tooling. That was completely unheard of, and I think it still is, right? And I don't think there's anything else out there that provides this kind of experience. But what that means is, and then the way that the initial idea that brought this in allowed us to then do other things like continuous testing and dev UI and things like that. But the problem is that, people were saying even at the time that this is going to cause a lot of problems, and it did, right? It did, and it continues to, because in order to implement this cool idea of live reloading stuff, what we used in Quarkus is essentially a class loader hierarchy, right? So essentially, the code that can be reloaded is in this runtime class loader, and each time something changes, we throw away this runtime class loader and create a new class loader with all the classes that are part of the application, while the rest of the class loader, like the base class loader, stays the same. Also, we have more class loaders because obviously that wouldn't be enough, right? We need more.
You can never have too many class loaders.
Yeah, exactly. Well, more. So this picture isn't even complete because with Holly's work, there's another class loader that's not even visible here. But these two class loaders on the left, because like Guillaume explained earlier, we have dependencies that exist only at build time. So when you're doing the NVM package, right? When you're running those build steps that Guillaume mentioned, the reason that this class loader exists is that we need to isolate the dependencies that exist in build time versus the dependencies that exist in runtime. So all this machinery that enables all this amazing productivity in Quarkus creates a massive amount of problems for us, right? Because, well, it's not a problem actually of the architecture itself. The architecture is sound, but what the problem is that almost all libraries out there that have to do weird things are not written with a hierarchical class loader model in mind, right? Because most execution environments like I don't know, Spring, Micronaut, whatever, right? Even micro frameworks, Kotlin frameworks, whatever. All those have a flat class loader. It means all the dependencies are loaded by one class loader, whether it's the base class loader or it's a very thin class loader that loads everything else except the Java classes. And that means that the library can do incorrect stuff and get away with it because when you have a single class loader, a lot of things just aren't a problem. But when you have multiple class loaders, if the thread, for example, if the library, for example, doesn't load resources in the proper way, using the thread context class loader, but it uses the class loader that it was given, its class in order to load the resource, that just doesn't work. And you have users coming to us and saying, this library doesn't work, right? It works in Spring Boot, but it doesn't work in your framework, so it's your fault. And from their perspective, it makes sense, right? I get it. So we've had to deal with a lot of that. Another wonderful thing that keeps on giving and probably will continue to keep on giving is class loader leaks in our CI, right? This architecture is super susceptible to class loader leaks. And a class loader leak is the worst kind because if there's a single class that leaks, it means that all the classes in that class loader leak, which means that every time you reload, you're having more and more instances of the class filling up meta space, which is the space that the JVM uses to load classes. And at some point, after some reloads, the JVM just doesn't have any more memory to load classes, reloaded classes, and it just blows up, right? Which is a terrible experience. And we're fighting with that even today. And it's super hard to figure out the source of these issues. Basically, it would be impossible without tooling like a YorkKit and profiles like that. But even with those, it's super hard to do.
So I got there's a question in the chat here. So with Quarkus 4, what would be so significant to name a version 4? You've probably been talking all along about that, but
yeah. Okay, no, that's good. Okay, so everything we've talked about here essentially won't change with Quarkus 4. Like this architecture won't change. Like the Gizmo stuff that Guillaume mentioned won't change. The Gendex, all that stuff is like, it will stay there, right? Well, what changes, when we're doing like a Quarkus, a new version, it means that something changed, something significant changes from a user's point of view. And the big change is that we're moving to Python. That's the big change, right?
Oh no, Stupendous follows as Rust.
No, so okay, the big change is that we are going to move to Vertex 5 and Netty 4.2, right? So those are like, I think that's like the main driver. And although like most applications will not be writing Vertex or Netty, much less Netty directly, the fact that these components are so core to Quarkus does warrant the need to change to bump a version, right? And because of that, we're also probably going to make other changes, like we'll probably move from Jackson 2 to Jackson 3. And probably like I think there's some like open telemetry breaking changes as well. Guillaume probably remembers more about that.
Do you have an example of a library that doesn't work in dev mode? Because they're saying they haven't encountered anything.
Well, yeah, we have, because like we are the people that get the issues, right? So yes, I've seen this multiple times. Like Liquid Base at some point didn't work, or Flyaway also didn't work. I remember some like Hibernate types library or something didn't work because it made the assumption, the extremely erroneous assumption, that in Java, all you need to load a class is the class name. Like that's the key, which is completely wrong. A class in Java is identified by its class loader and the name. So when you give it a name, you can't cache the loaded class, right? So the library, like this Hibernate types library, was doing that, right? And when you go to maintainers and you say like, this is wrong, they're like, I don't give a shit, right? It works in Spring Boot. Nobody's complaining. It's your fault. And then you have to like, I remember I had to spend like a few hours trying to convince this person, and then essentially like give them a reproducer and without Quarkus that said, okay, here is what Java can do. And if I do it in your library, it blows up. Right? And that's when they got convinced. And I get it, right? Like people will say like, oh yeah, Quarkus is too complex. I don't want to deal with it. Give me something that doesn't have Quarkus that shows me a problem. I get it.
So I guess another question is or I guess more of a comment. Dev mode doesn't like annotation processors too much.
Well, yes, that is correct. Currently, there's been a lot of work on that. Like Stefan had done work to configure it. But there's also this latest work from a super good contributor, Martin from Germany, if I remember correctly. Like he wants to make MapStruct work great. So he's introduced some kind of like I don't remember exactly what infrastructure changes that will allow MapStruct to work a lot better, right? And then I'm sure that can be used in other ones as well.
Yeah, I mean, I use MapStruct a lot. Lombok, I'll just say people shouldn't use it, in my opinion.
Well, Lombok isn't even an annotation processor, so yeah. I mean, I personally don't care. I'm never going to lift a finger to fix a Lombok issue.
And sometimes it works, but what Georgios was mentioning about the class loader leaks means that every time you reload dev mode, you will have a new class loader that stays with the new one, and then you pile them up, and in the end you will have an out of memory for either the heap or the metaspace. And so even if you don't see that things are not compatible, sometimes you have we have some issues with Rest Assured, for instance, that we are trying to solve because they are using Groovy, and Groovy is especially and ask ChatGPT if you don't trust us, but it is especially prone to memory leaks, and so we have to class loader leaks. So we have been trying to solve these issues. So yeah, there were libraries that simply didn't work.
And That's a very good point. Like when you introduce this kind of architecture, you see what can go wrong. Like what Guillaume's alluding to is that simply starting like a background thread, right, can cause a class loader leak, because that thread will use the context class loader of whatever, will set its context class loader to whatever class loader loaded it, right? And if that thread continues to exist and doesn't get stopped in some way, that thread will always hold on to the context class thread and do that again and again and again for each reload. And like Guillaume said, you get blown up, right?
And the funny thing is that we actually fixed some bugs that were present in the traditional application servers. So the traditional application servers, they actually do some reloading. When you redeploy an app, they will stop the class loader, stop the app, and restart a new one. And we had a few things for which we actually fixed something, because in Quarkus, the problem was very visible because we were reloading so many times. And the bug was present for like 10 years in the traditional app servers, but they weren't able to pinpoint it because they weren't doing that many reloads. And we had some users saying, oh, I had been struggling. I fixed something in Anvers, I think, if I remember correctly. And this particular person was struggling with this for years in the traditional application server. And we were able to fix it nowadays. And it's also fixed now for the traditional application server. But the fact that with Quarkus, it was so visible allowed us to say, oh, the issue is there. And we were able to fix it right away. So what we do to fix these leaks and these problems actually benefit to the whole ecosystem. It's not specific to Quarkus only.
Mm-hmm. Yeah, like Guillaume said, that's the key point. That Quarkus makes these erroneous assumptions that libraries make. It makes them visible, right? That's the whole point. And Guillaume, did you want to add something about for Quarkus 4 other than what I said?
No. It's consistent with what we will do.
Okay, cool. Okay, yeah. So let's get to Vertex, right? So here, like, Eric, was that your question or was that from a user?
It was from a user.
Okay, from a user. Good. Okay, so here's my take, right? And I've told this to a lot of people. Like, Vertex is super good, right? It's amazingly bulletproof. What it does amazingly well, right? We building on top of it and providing like stuff that users then consume directly. We would not want to have to write all this, right? Because Vertex like just does so much stuff for us behind the scenes. That said, Vertex, in my opinion, right, and I come from the Spring world. I hadn't done much reactive before starting working on Quarkus, right? Which I assume is the case for most people, right? So with that said, I think Vertex is like very hard to work with. Not because it doesn't have good APIs. The APIs in Vertex are very good because you have to consider that Vertex has to handle like every possible like HTTP scenario, right? So it has to have or APIs that consider everything, and it has to be reactive. So all that means that if you're like consuming Vertex like without, let's say, Quarkus, or with a very thin layer of Quarkus, it's, in my opinion, it's very hard to do, right? And I believe it should only be done for very specific use cases where you know, like, you need to squeeze the absolute max out of your underlying hardware, right? And that's it. Like, Vertex, I believe, is amazing. Like, I personally don't have to want to like implement HTTP 2 or 3 every time like a new spec comes out, right? I don't want to have to deal with all the low-level neti stuff that changes all the time. I don't want to have to be the one that reacts to every HTTP-related CVE, right? Like the fact that we have amazingly good people working on Vertex doing this for us is a huge win. Like obviously for Quarkus, but for the community as well, right? Because there are other projects that use Vertex and they're not Quarkus, right? And that's great. And that means that when HTTP3 comes around, or like support for our urine comes around, like we can just consume it in Quarkus, right? Like just in air quotes, we bump to like, let's say Vertex 5, and we get these features for free, right? So that's my opinion. I don't know what Guillaume and you folks think as well.
Yeah, and most users actually don't see Vertex at all.
Mhm.
Most users, they are doing JAX-RS, some REST application. Vertex is underneath, but they don't see it. They don't see the reactive part either, except if they want to actually implement something reactive. They don't see it. It's all underneath. So what Vertex provides us is foundations on top of which we can build. If you are a Quarkus user interested in Vertex and doing some low-level stuff in Vertex, you can do it. But if you are a Quarkus user who just care about doing some blocking JAX-RS app, then you absolutely don't care about Vertex and the fact that it's underneath, except that, well, it works well and it will perform well. And so that's really important to understand. You don't have to go reactive when you do Quarkus.
I always say about this part of the Quarkus architecture that the Quarkus team suffers so that you don't have to.
Yeah.
That's true, yes. And like with the upcoming change to Vertex 5, which we'll do in Quarkus 4, yeah, there are going to be a lot of changes that we're going to have to adapt to, right? No question. But yeah, the good thing here is like Quarkus like builds on because we build on Vertex, and like the Vertex team is part of IBM too, right? So we have a very close collaboration. That's a great thing about like a big company like Red Hat, now IBM's, that like you need stuff from Hibernate, you go talk to the Hibernate team, you work with them very closely. You need stuff from Vertex, you work with them very closely, right? So it's not just like one little island and you're trying to stay on prevent yourself from drowning, right? You have help from a lot of great folks.
So fun question: how many of this stuff is going to be vibe coded?
None. No. I look. I'm going to be like very forthcoming with this, right? I would say like most people on this team are skeptical, let's say, of how much AI can do for us. I am less skeptical. I'll say that I'm less skeptical, right? But I'm like I've never been able to get it to do anything like super complicated in a very good way. Now it's AI is amazingly good at like doing stuff like some kind of refactoring that I'm like, okay, this is like too big. I just don't want to do it. But like with AI, that can be done like 10 seconds, right? But it's not very good at like designing good APIs, right? And sometimes like it will like solve problems in a way that I never even thought of, and that's great, right? But what that means is like if you're going to incorporate AI, which I hope to, it's like, okay, I'm not going to like let it vibe code. I might like tell it what I want to do and see in what direction it's going to go, right? Maybe give you a good idea. But the fact that like we have so much accumulated knowledge, right, and so much history in the project, and we know most of the nuances between us, not me or Guillaume or you guys, right? Just like everybody between the team. I think that like we can definitely get stuff from AI, but I don't see like anything very significant. Very complex like Quarkus, and not only right, being like the developers being replaced for it. Right? That's my take. I don't know what you folks think.
Yeah, I agree. For me, I feel like these AI tools, if I have like an assistant that I can go like look up stuff for me, it's great at doing that and bringing ideas. But at the end of the day, I need to validate the ideas, and a lot of times it just gives you crap and it just doesn't work. uses an API from a different version that what you're using, and classes don't exist or whatever.
But on the other hand, for example, like for ASM that Guillaume was saying earlier, you can give it what you want to do. Like you can give Claude what you want to do, and it'll write like great ASM for you, right? And stuff that would take me like hours to write to get the like, I don't know, like the little dots right, like the binary versus regular class name. All that stuff is like, it's so weird. It can just do it, right? So there's some stuff that's like really good.
Yeah, for things that are extremely well covered on the
Exactly.
internet, you can get it to do. Typically, we have a very thin JSON layer in Quarkus, which allows us to do some very basic JSON stuff without bringing up Jackson or JSONB or whatever. And it didn't have any test at all. And Alexei did some changes to it lately, and he was like, "Oh, there's no test." And I said, "Okay, this is typically one case where JSON is very well known." And I asked some AI tool to say, "Okay, generate me some tests." And I was a bit specific about what I wanted it to test and how I wanted it to do it, and it generated something that was relatively nice and usable. And on the other side, sometimes you will do things completely crazy, and it will iterate. So it will generate something relatively good, and then it will run the test, and the test doesn't work, and then it will go with some completely crazy and stupid reason for the test to not work, and it will screw everything up with some changes that make no sense, and it can be a bit hard to track, follow, and anyway, it's an interesting tool. But when you are actually inventing stuff and experimenting with stuff in a very specific way, in a framework that is not your typical what you can find on the internet thing, it can lead to weird results most of the time.
You know what? I for example, though, I think would be very good. I haven't tried this, but this is just an assumption that I think it would be very good. I think it could be very good, for example, in writing the code that we have for supporting the binary file, that DAT file we have that is then used by the runner class loader. I think like all that code, it could probably, if you like tell it that, you know what, I want the binary file to have like this, and this list, I'm almost certain it could write that like flawlessly, right? Instead of us, where each time we have to make a change, like you have to think about, what am I supposed to do with this like output stream or whatever those things are called. Like, like you said, for focus things, I think it can be really, really good work.
Yeah.
I think we're like way over anyway, right? So we're probably gonna have to continue this like on a volume 2, right? Because there's still a lot more to go. Oh yeah, there's a lot more to cover here.
Oh yeah, yeah. I think that's volume 2, isn't it?
So when you did Devox Belgium, was it like a 3-hour deep dive or a 60-minute session?
No, it was 50 minutes, but we had to like run through like half the second half, right? Because again, we didn't time it greatly. Oh well.
And they didn't have us interrupting them.
Yeah. It was I speak, you listen mode. Yeah, we'll definitely have to do a second, because when I talk about this stuff, I've been getting people asking me, well, what's the secret sauce? Like, and I know, Holly, you've talked about that too. You've got some slides that I've begged, borrowed, and stolen from you on occasion. So I think like getting more into that, because like you said, I think people understand the user experience, but like how it actually works and with the thought process behind it, I think a lot of people are starting to ask about.
And I think that discussion I just love that discussion of the trade-offs as well, because nothing's ever simple, right? You know, it's always all trade-offs.
Yeah.
Yeah, and that's sometimes hard to explain, because you have someone coming from the outside with this idea and say, okay, we should do it like that. And you're like, yeah, but it's not that simple. And we have to, and sometimes, the solution is not perfect. It's not ideal, but still it's the best we can do with the constraints we have. And that's what makes it hard. And also it's sometimes hard for us to figure out why we took these decisions 3 years ago and all the technical details that led to this particular trade-off. And so that's why we have this architectural decision record that we should probably use a bit more. But yeah, it's all about trade-off.
I agree. Like ADR is great, but I should say, like, for a project that has not used the most, I think like we've done a pretty good job like documenting stuff like via discussions on GitHub, and like the commit messages. Most of the commit messages are pretty good, right?
Yeah.
You can usually find your way from one issue to a pull request or vice versa, and then back. That shows you like what happened. Like there are no commits in this project that say like, or at least like aside from maybe like some very initial stuff that say fixed, or like now everything's good, or someone told me to do it, so I did it, right? There's nothing
changed this file.
Yeah, exactly.
This is something we see a lot more. So I thought we were done with that, but I have seen people doing that a lot more now, that they are using AI to code, and that so that it's all commits are a big mess of.
Yeah, I agree. Like AI commits are terrible.
All mixed up, and you end up with commit, fix, whatever, and you end up with a history that is extremely bad. And for a project that you want to outlive you and that you want to install in time for a long time, knowing the history of the project is extremely important, and that's why we are extremely strict about that.
Yeah, I think we should put a lid on it, because we can go on and on and on and on.
Yeah.
Yep, I was about to go on my rant about commit history, but I'm
Oh,
going to, no, I'm going to sit on my hands, because as you say, we could just go on for hours. So, and I think this is probably a good time to wrap it up. But
Yeah, sounds good.
So, yeah, thank you everybody for the questions, really good questions, and yeah, thank you Guillaume and Georgios for
we'll
super
schedule
interesting.
this like for beginning of next year, right?
Yeah, I think we're booked until maybe mid-January. So yeah, so sometime sort of after that, we'll get you back for part 2 when you've already forgotten all of the questions from part 2 from part 1 rather, and we start over.
Excellent.
All right. Well, yep. Thanks everybody, and have a good day, evening, whatever time of day it is for you. And we'll see you. Do we have an episode next week, or are we on vacation?
We do. I think next week is our last one, and then we go on vacation.
Last one for the year. Excellent. Yeah. All right. Well,
excellent.
All right. See you later, everybody.
See you all.
Thank you. Bye.